Hi, someone asked me to do this problem. I'm going to go ahead and work it out. This is not one of the assigned problems. This is what they call a recreational mathematics problem. It says, on a die, the sum of the dots on the opposite faces is 7. Two six-sided dice are placed together on top of one another on a table as shown in the figure below. The top and bottom faces of the bottom die and the bottom face of the top die cannot be seen. If you walk around the table, what is the sum of all the dots on the visible faces of the dice? Okay, so when I first read this problem, I had to read it twice, because the idea is you have this table and then you have the two dice on there, and I'm not going to really be able to draw this because I'm drawing it improperly. Come on. Yeah, I just did it again. Okay. The dice. Now this face here is not going to be visible, and the face down below you can't see. Then you have another one on top of it. You can see the top, but you can't see the bottom there. But what you can see on each of these die, it really doesn't matter what the numbers are that are showing so much. Make that to a dashed one. Okay. Is you see the 4 out here, and you know 3 is on the other side, so that's there. But what's really important here that we're seeing is that this side out there, this side there are there, so that's 7. This side is here, and that side there, that's another 7, because they added to be 7. And then you have the top die, and on the top die again you have this side and that side, so there's another 7. You have this side and that side, there's another 7. And then you have one more thing. You have this top side, you can see, and that's a 1. So plus 1. So 7 plus 7 is 14, 21, 28, 29. And that's the sum of all the dots. Because you don't know that, how do I say this, the top of the bottom die, or the bottom of the bottom die, or the bottom of the top. So not knowing that one and that one, that's taken away one of the pairs, and then not knowing the bottom there, you do know the one on top. But the point is, you know 1, 2, 3, 4 sides are going to be visible, so the pairs of opposites, I should say, 4 pairs of sides are visible, so that's where you get 7 for each of those pairs, plus the 1 from the top is 29. Okay, I hope that helps.